All right, our first lesson is on right triangle trigonometry. So what we're doing with is right triangles. And before we do anything with the trigonometry functions, sine, cosine, tangent, we want to be able to identify parts of the right triangle. So in this example here, in right triangles, we deal with theta, or sometimes an angle determined by the vertice letter. So theta is going to be the angle that determines the different parts of the triangle. And there's three parts of the triangle that we're going to use. Based on where the angle or theta is, we're going to have three parts. Again, the first part is going to be across from it, which we're going to call opposite. The second part is going to be the side that touches the angle, and that's going to be called adjacent. These two are going to switch depending on what angle in the triangle is used. The third part of the triangle will be called the hypotenuse. So combining these three sides, we're going to form different trig functions. The first trig function is sine, and it's abbreviated SIN. It's not called sin, but we call it sine. And it's called sine of theta, meaning some missing angle. And sine is going to be opposite, the length of the opposite side divided by the length of the hypotenuse. Okay? And we're going to go through an example in a second using tangent to show you how this works. Cosine is going to be adjacent divided by hypotenuse. And tangent, which we're going to focus on the rest of this lesson, is going to be opposite divided by adjacent. Okay. All right, so why this is important is because in the past, with right triangles, to find side lengths, we've used Pythagorean theorem. So in this case, we've had two side lengths, and to find the third, we would use Pythagorean theorem. So what happens now is we're going to have problems with right triangles in which you have one side length and one angle, or sometimes two side lengths, but you want to find an angle, and this is going to be determined by right triangle trigonometry. All right, so now that we have the identification of the parts of the triangle, let's kind of put this into use. Okay, so here's an example where they want us to write the tangent ratio. So we have to understand ratio means fraction. So we want the fraction related to angle A, and then second part will be the fraction related to angle B. So if we look here at angle A, this is going to be our theta. So based on this, we know that this side here, this 20, is going to be opposite. And this side here that touches the angle is going to be the adjacent. And because it's tangent, right, tangent is going to be opposite over adjacent. So what we're going to end up doing for this is to write the ratio 20 divided by 21. Again, 20 coming from the opposite side, 21 because it's the adjacent side. When we do tangent of angle B, the opposite and adjacent are now going to change because now theta is up here, which makes 21 now the opposite side, and 20 would be the adjacent side. So tangent of B is going to be 21 over 20. All right, so it's important to understand this when you have a problem, to know what your theta is, what angle you want to use as your reference point, and what sides are given. So right now we're dealing with opposite and adjacent. So we have this acronym, and the end part of it is called TOA, tangent, opposite, and adjacent. The whole acronym here, the mnemonic, is SO, CA, TOA. And what that has to deal with is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So this is a way for you to memorize which parts of the triangle opposite, adjacent, and hypotenuse go with which trig functions. So this is an easy way to remember that. Okay, back to problems here. So in this example here, they want the tangent ratio. So tangent, we know we're going to use opposite over adjacent. And we want to start with angle K. So in this case, our theta will be angle K. So based on this, we know using tangent, this is going to be opposite. And so the tangent of angle K is going to be 3 divided by 7. That will be the ratio for tangent. When we go tangent of angle J, this is going to be now 7 over 3 because here's our theta. So 7 becomes opposite and 3 becomes the adjacent side. So we end up having these ratios. At this point, you should at least understand how to form ratios based on side lengths using tangent. We could easily have used sine or cosine, which we'll do in a future lesson, but for now, at least understanding how to do this. By doing this function here, we are going to be able to find missing angles of triangles using these functions of these triangle problems. Okay, let's look at another example here. So before I go into this, I want to explain a couple things. There's two types of equations we're going to use a lot in this particular unit, not just this lesson, but in the unit. So if you recall from 8th grade math, if we had an equation like this, 8 equals x over 4, how would you go about solving this? Well, we know we have to do opposite of the variable. And in this case, we're dividing the variable by 4. So opposite is going to be multiply. So we would officially multiply both sides by 4 to get rid of this, to get the variable by itself, which would leave us with 32 is equal to x. And if we were to check it, 32 divided by 4 is equal to 8. So that works out. So one strategy we're going to use for equations is going to be to just multiply the bottom across the equation. That's going to be our shortcut wording. There's another kind of equation we're going to see where we have the variable on the bottom. Now, what are we doing to the variable? We're dividing it by another number. So like we did in the previous example, we're going to cross multiply this. So we're going to take this x and multiply it this way, which we would end up with 4x is equal to 8. The last step would be now to divide by 4. So in the end, we end up with this fraction, which we know is going to be 2. However, I want to point out one thing to you, because this will be a shortcut we will use in class, is this 4 and x, in the end, after we do this step here, is just going to change places. And so this is going to become very valuable for us to eliminate mistakes in our algebra. So if the variable's in the bottom, we're going to trade spots. If the variable's on the top, we're just going to multiply. So that's going to be the two equation types that we're going to see in this trig unit. Not just for tangent, but also sine and cosine. So if we look here at this example, we're going to use 54. And if we use 54 as our theta, that means w is going to be opposite and 10 is going to be adjacent. So how we're going to set this up is going to be tangent of the angle. In the previous examples was a letter. In this case, because we have the angle, we're just going to substitute that in. Is equal to w divided by 100. So, w divided by 10, opposite over adjacent. So like the example I gave you a minute ago, the variable is on top. So how do we solve this? This tangent 54 is actually a number. So what we do is we cross multiply this. So 10 times the tangent of 54. And tangent of 54 in the calculator is 1.376. So we're going to take 1.376 times 10, and that will give us our length for w, which is going to be 13.76. So this is one example on how we solve for a missing side length when the variable is on top. On this example here, we could do it either way because both angles are given. We could do it either way over here as well. However, for this one, for sake of example, I want you to use tangent of 33 for this. So if this is the theta, this becomes opposite, this becomes adjacent. And so what we end up having is tangent of 33 is equal to 2.5 over w. And if you recall from a minute ago, when the variable's on the bottom, we're going to change spots. So this w is going to end up here, and this tangent 33 will end up here. So I have the step that we did, but this is where we're going to end up. So we have w equals 2.5 over tangent of 33. So at this point, there's a couple ways you could do it. To keep it uniform, let's convert this tangent 33 to a number. And in trig, whenever we use tangent, sine, or cosine of angles, we want to take it to 3 decimal places. So we're going to convert this here, which is going to be 0.649. So at this point, we can take 2.5 divided by 0.649, and we're going to get a length of 3.85. So this missing length here is 3.85, and if we round it up, it would be 3.9. So here's two different examples of solving equations, which we're going to see a lot of in this trig unit, where the variable is missing on top or the variable is missing on the bottom to find missing side lengths. All right, here's a real world example. People always ask, what do I need this for? Well, trig is very useful for finding heights and distances of objects when you don't have all the variables needed to solve it traditionally. So here's an example where you're standing 125 feet away from a tree, and you have a measurement tool which you can measure to the top of the tree to be 32 degrees. So if you look at this, here's our theta. The tree, the height of the tree, which we don't know, that will be our variable, is going to be opposite, and then the 125 will be adjacent. And so what we have is tangent of the angle is equal to the variable, which I'm calling h, the height, divided by 125. Because the height is on top, we're going to cross multiply these. So if you take the tangent of 32 times 125, you'll end up with the height, which is going to be approximately 78 feet tall. So this is a way we can estimate heights pretty accurately in nature in the real world with a little tool and a measuring tape of some sort. All right, now the last thing we're going to do is find missing angles. So far we found ratios, we found missing side lengths, now we're going to find missing angles. And when we found missing ratios, I mentioned how that's going to help us find missing angles. And so we're going to come back to that. And so the button we're going to hit on the calculator is called the tangent inverse because we're dealing with tangent. You would use the same corresponding button for sine and cosine. So in this case here, we want to find the measure of angle y. So that's going to be our theta. So in this case, here's theta. So based on theta, we know that 100 is going to be opposite and 41 will be adjacent. So when we set this up, we're going to set it up, the tangent of y is equal to opposite over adjacent. So at this point, we're going to divide this fraction, and we're going to get 2.43. So now at this point, here's the ratio step that we set up earlier. Now, to take it a step further, we divide it to get a decimal. Now, to get this value for y, just like we solve equations, how do we do the opposite of this? We're doing tangent times y, so the opposite will be the inverse tangent, which is going to be the tangent -1 button of the decimal. So the decimal and y will change spots, and we add the inverse sign here. So on the calculator, we would do this and get 67.7 as your answer. If you had a trigonometry table, you would go down the tangent column until you found this decimal value and move over, and it would say approximately 68 degrees would be the answer for this particular one. If we go over here, we still want to find angle r. So angle r will be our theta. So based on that, 47 would be opposite, 41 would be adjacent. So we set up our function tangent of r is equal to 47 divided by 41. We divide 47 by 41 and we get 1.14. And now we're going to switch. The r and the 1.14 are going to switch spots. And we're going to take the tangent inverse of that. And we're going to end up with approximately 49 degrees for this particular example.